Hi everyone. In this lesson, we are going to talk about algorithms. Algorithms is one of the main concepts in computer science. That's why we are starting this course on programming by studying algorithms. It is widely used in many areas. For instance, in mathematics, in physics, and also in a daily basis in our lives, we are using algorithms. It is a concept that is older than computers. It was created and used long before computers were created. So let's start with an informal definition of what an algorithm is. It's a finite sequence of well-defined steps. When the steps are executed in the given order, they solve a problem. The order of the steps are defined by the sequence of the steps. These steps can be executed without knowledge of the problem that is being solved. Meaning, it doesn't matter whether you have knowledge of the problem that is being solved or not, you must be able to execute the algorithm. The steps has to be executed by a computer. So, not all the algorithms are created to be executed by a computer, but because we are in a course that is about programming, we are going to say that these steps has to be executed by a computer. Therefore, every step needs to be clearly defined in such a way that a computer can execute it. Let's see the following example. Calculate the perimeter of square given the length of one side. So the algorithm will be as follows. Assign the value of the side of the square to a variable named side. So just for now, we can see a variable informally as a container where you put values. So you can later access those values. Then the second step of this algorithm will be to calculate the perimeter using the formula 4 times the length of the side. And the last step, it will be to print the value of the perimeter. As you can see, it is a very simple algorithm, and this algorithm will solve our problem, which in this case is to calculate the perimeter of a square given the length of one side. So let's see a slight variation of the previous algorithm. In this case, all the steps are the same. It is just we are now using a different formula to calculate the perimeter, which is equivalent, obviously, but it is not exactly the same formula. Here we are summing the length of the side 4 times instead of multiplying the length of the side times 4. So these are considered two different algorithms, although both of them will give you the same result. Usually, several algorithms solve the same problem, and we will see later on how you can decide what algorithm to choose. So we saw that there are several algorithms that solve the same problem. Then which algorithm should we choose? Well, it depends. It will always depend. The algorithms are compared according to time complexity and space complexity. Basically, these two are the main criteria that one have to follow when we want to choose one algorithm among several others. Time complexity refers to the amount of time that the algorithm needs to be executed and give the result, and space complexity refers to the amount of memory that the algorithm needs to be executed and give you the result. All the algorithms has certain characteristics that are very important. So anytime we design an algorithm, we need to consider all these characteristics. So the first thing is an algorithm solves a problem. We don't have an algorithm unless that specific algorithm solves a specific problem. The steps that we give to solve an algorithm have an order, and that order is the order that everyone has to follow in order to solve the certain problem. The algorithms are finite. It means they have a finite number of steps. Each of those steps have to be executed in a finite time, and the execution of the whole algorithm will finish after a finite number of steps are executed. Also, the steps must be clear, very clear and unambiguous. So the steps have to be well defined. Everyone has to understand what is required to execute each step. As an example, you cannot have a step that says calculate the perimeter. You have to specify how to calculate it. What is a formula? What value you are multiplying? So for someone that doesn't know what is a square and what a perimeter means, it still can execute the algorithm and get the result if the person follows all the steps that are specified as a part of the algorithm. We can represent the algorithm in three basic ways. We can use natural language, which is the same way that we speak. So we write an algorithm the same way that we speak. We will see some examples. We can use pseudo-code, which is a kind of similar to a programming language, but is not as formal as a programming language. Therefore, you can use symbols that you prefer to use. You can also use your own structures as long as they are similar to the ones that have been used in a programming language. We also have flow diagrams. For the flow diagrams, we are going to use certain symbols to represent the structures that we need to use in an algorithm. For instance, we are going to have a symbol to represent the start and the end of the algorithm. We are going to have another symbol to represent calculations, another symbol to represent input or outputs, and another symbol to represent decisions. We are going to see some examples later on. How can we use decisions in algorithms? So let's see this example. As you can see in the left side of the screen, we have an algorithm expressed in natural language. We are saying the first step is to assign the value of the site to a variable named site. Second step, calculate perimeter equal 4 times site. And the last step is print the value of the variable perimeter. So if we write that algorithm in pseudocode, it will be something like what you see in the middle of the screen. The first step will be read site. Second step, perimeter equal to 4 times site. In this case, we are just using the variable names. We don't have to say is the variable perimeter or calculate the variable perimeter. And the last step is print perimeter. And check our flow diagram here. We have the start, then we read site using the symbol for input or output. Then perimeter, the next step is perimeter equal to 4 times site. As you can see, is a rectangle that shows that it's a calculation. Then we have the symbol for output, which in this case is print site. And then we have the symbol that represents the end of the algorithm. In this lesson, we saw a definition of algorithm, 3 main ways that we use to represent an algorithm, which are natural language, pseudo-code, and flow diagrams. You just must know that we don't use natural language to represent algorithms in programming. We mainly use pseudo-code. Flow diagrams are not too much used, but they help you understand how the flow occurs in an algorithm. Thank you for watching. I'll see you on the next lesson.